Hello. Today we're going to work on adding fractions with unlike denominators. Focus on using equivalent fractions and visual models. So take a look at my first problem that I'm going to walk you through. Let's see. And just put this down here. Okay. So Anaya drank 2/3 of water before lunch and 5-6 liters of water after lunch. How much water did Anaya drink today? So the first thing I do is I think about my operation and I look to see, of course, I have my numbers. I'm gonna highlight those real quick, 5, 6, and 2/3. And I see that I also notice I see that we're looking at before lunch and after lunch. And we're looking at how much did Anaya drink today. So that's telling me that I'm combining those two totals. And since I'm combining those two totals, that means I'm adding. So the first thing I'm going to do is I'm going to visualize my two fractions. I'm going to draw two rectangles. And I see that I have 2/3. So I'm going to just draw 2/3. So 1 and 2. Shade that in real quick. Shade that in real quick. And then 5, 6. 1, 2. And then cut it this way. And then you see I've got 2/3 and 5, 6. Now I look and see that I can't combine those two yet because they're different sizes. So I think I go, okay, so I see if 6 is a multiple of 3. I start with the smallest denominator and see if I can count to my largest denominator. So I'm just gonna right here on the bottom is gonna count. So do 3, 6. Oh, I can count by 3s to get to 6. And I see that I do that 2 times. Since I do it 2 times, that means 3, thinking 3 times 2 is 6. To get to 6, I just need to divide my 2/3 and cut them in half. So I just draw a red line there to show that I'm taking my 2/3 and I'm turning it into 5, 6. So then I'm just gonna go up here, cross this out, and now I have 4, 6. Now, when adding fractions with like denominators, I have to remember that I keep my denominator the same. So the 6 will still be my denominator. And then all I'm going to do here is I'm just going to count the number of 6 that I have, and that's going to give me my improper fraction. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 6. Of course, 4 plus 5 is 9. So right now my improper fraction is 9, 6. And as you know, we don't really talk in improper fractions. We talk in mixed numbers. So how I'm going to take 9, 6 and turn it into a mixed number? Well, that's actually not that difficult because all I'm going to do is just draw it out. So I'm going to draw another rectangle. And I'm going to turn it into 6. And then I just count the number of rectangles I currently have. So I have 1, 2, 3, 4, 5, 6. Now I have 6 over 6. I know that 6 over 6 equals 1 whole. I'm just going to go ahead and shade this entire rectangle just to represent that I'm using a whole here. So I see that I have 6 over 6, but I need 9, 6. So I need to draw another set of 6. Let's just draw another rectangle. Break it into 6. You might notice that my my rectangles aren't perfectly drawn, and that's fine. You know, the goal is to help you visualize it so you see how it works. So I have 1, 2, 3, 4, 5, 6. So I need to do 7, 8, 9. Okay, so I have 9, 6. So then I just, of course, I'm going to shade those in to represent that I'm using it. So I see that I have one whole, 1 and 3, 6, meaning that 9, 6 equals 1 and 3 over 6. Well, there's one problem with that. I can actually reduce that fraction. How do I know if I can reduce the fraction? Well, I just run through my numbers 3, 2, 3, and 5. If I can divide them by those, that means I can reduce them. If I can divide both my numerator and denominator by them. So I look at the 3 and I go, okay, well, can I do 2 divided by 3 evenly? No, doesn't work. Can I do 3 divided by 3 evenly? Obviously, it equals 1. And then, of course, 6 divided by 3 is 2, meaning my final answer is going to be 1 and a half. And another way that I can tell that this is true is I know that also if my numerator is half of my denominator, I mean, if I take my denominator, divide it by 2, and it equals my numerator, that means my fraction is equivalent to 1/2. So 1/2 is equivalent to 3, 6, meaning, and then 9, 6 is also equivalent to 1 and a half, which 1 and a half is my final answer. All right, so before I finish with this problem, I want to show you the more traditional method to solve this problem. So I have 2 over 3, I'll redo that because I'm going to need some room. 2 over 3 over 5, 6. Okay, so I have those set up. I have 2 over 3 and I have 5, 6. The first thing I do is I list out my multiples of 3 and 6. Just do 3. I think that's plenty for this problem. So I'm going to list out my multiples here. So I have 3, 6, 9, and then I list out my multiples of 6, 6, 12, 18. So I look at my numbers and I say, okay, I look at what I call for the least common multiple, or LCM. And my least common multiple for both of these is 6. So I have 6 and 6. And that says, okay, your new denominator is 6. So I give myself some space, and over to the side, I put 6 and 6 as my new denominator. Now, to determine what my new numerator is, I have to multiply my old denominator by my new denominator of each fraction. So I ask myself, 3 times what equals 6? And I just go through my multiples. 3, 6, then I got 2. So I'm going to take the question mark out and put a 2 there. And whatever I do to my numerator, to my denominator, I do to my numerator. So I know that 3 times 2 is 6. 2 times 2 is 4. And you're like, well, Mr. G, how do you know that you do? Why do you know 2 over 2? Like, why is it you do the same thing to the numerator as you do to the denominator? Because whenever you have a fraction where the numerator and denominator equal the same, you have it's like multiplying a number times 1. So when I multiply 2/3 times 2 over 2, I'm essentially multiplying it by 1. Now, and I basically am taking my 2/3 and making those pieces smaller. I take my 1/3, cut it in half, my other 1/3, cut it in half, and that gives me 4, 6. I look at my 5, 6. Now this one's pretty simple because I know that 6 times 1 equals 6. So I do 5 times 1, and that gives me 5. Now I'm doing 4. Now I'm doing 4 plus 5, and I know that 4 plus 5 is 9, and then 6 is my denominator. So 9, 6 is my answer. So to convert this into a mixed number, there's a different way to do it that's a little simpler. I'm going to use division. I just say simpler, just different. So I'm going to divide 6 into 9 just like this. I ask myself, okay, How many times does 6 go into 9? 6 goes into 9 one time. 1 times 6 is 6. Then I subtract 9 minus 6, which is 3. Can't go any further. So then the 6 is still my denominator. The 3 is now the remainder here is now my numerator. So 1 and 3, 6 is my answer. And like we talked about earlier, it also equals 1 and a half. I'm trying to get this screen to go away. Okay, 1 and a half. So there you go. All right, I'm gonna clear this out. We're gonna look at one more problem together. And one thing that might be helpful is if you kind of follow along as I do them on your paper. So Sarah read some chapter books over the weekend. She read 2/6 of the book on Saturday and 5/12 on Sunday. How much of the book did she read over the weekend? So we're looking at the total amount she read the book over the weekend. So I always, of course, acknowledge my fractions. I have 2/6 and 5/12. And then right away I notice I'm combining the amount that I read over the weekend. I notice that I'm adding 2 unlike denominators. So I'm going to show you the traditional way first and then draw out the model second. So kind of flip it a little bit. So I have 2 over 6 plus 5 over 12. Now, right away I notice my denominators don't match. So I'm going to find what's known as the least common multiple. So I'm going to count by 6s and 12s until I arrive at my LCM. I'm just going to do it 3 times. So 6, 12, 24. And then 12, 24, 36. And you might notice that 6 and 12 share a lot of similar factors. I could turn these denominators to 24, but that's just too much work. So my least common multiple is 12. So that means my new denominator is going to be 12. So I give myself some space, go ahead and write my new denominators. I'm adding. I know that, so I'm going to go ahead and start converting. So I know that 6, I ask myself, okay, 6 times what equals 12? It's 2. 6 times 2 is 12. And then I do the same thing. So 6 times 2 is 4. That's my new numerator. And then I look at the bottom. I'm like, okay, well, 5 times 1 over 1, obviously, because 12 times 1 is 1. And you don't have to write down the 1 over 1. I'm just showing you in case you see like a 1/2 plus 2/3 kind of situation. So then I do 5 times 1, which is 5. Not bad. Now I just add my 2 numerators together. Because remember, we don't add the denominators. We keep them the same. So I know that 4 plus 5 is 9. My denominator is 12. Right now, my fraction is 9/12. I don't have a mixed number, an improper fraction, so I don't have to worry about a mixed number. But I need to check to see if I can reduce. So I go through and I say, okay, can I do 9 divided by 2? No. Can I do 9 divided by 3? Yes. Can I do 12 divided by 3? And if you're unsure, just count by that number you're trying to divide by and see when you arrive. So like with 12, say, well, let's try to see if we can divide it by 3. 3, 6, 9, 12. Oh, yeah, you can, because 12 is a multiple of 3, meaning I can divide it by 3. So I divide my 9 by 3 and my 12 by 3. So I'm essentially dividing it by 3 over 3, which is the same as dividing it as 1. 9 divided by 3 is 3. 12 divided by 3 is 4, meaning my final answer is 3/4. And that's going to be the answer you see on a multiple choice problem. Now let's go back through the visual models one more time, just to make sure we see visually how this works. clear my screen because I got a lot going on here. So I'm going to go back and I'm going to have, so I have my 2/6 is going to go here and my 5/12 is going to go here. So I'm going to go ahead and draw me some area models. And then I'm going to break my first one into 6. I always kind of recount them because sometimes, especially with these bigger denominators, I miscount them. I just cut it in half. And then, of course, I shade what I need. It's kind of shady. 1, 2, 1, 2, 3, 4, 5. Remember, when you're creating these visual fractions, you know that the denominator is how many total parts of the whole you have. Your numerator is how many that you're using. So your numerator is the shaded part. So now, I see that I got an issue. I have different denominators. So I'm just going to see if I can count by 6s till I get to 12. So 6, 12, yep, 2. So I know since it's times 2, I'm going to do 6 times 2, which is 12, which I'm going to turn my 6 into 12. So I'm just going to grab a little line here, do it red so it sticks out. Boom. So now I have, and I'm going to write this to the side. Now I have 4 12ths. Just like before, I'm going to count the number of 12ths, and that is going to tell me what my new added fraction is, what my sum is. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 12ths total. Boom. After I have 9 12ths, I then go, okay, same as before. Can I divide it by 2? No, but I can divide them both by 3 evenly, and that equals 3/4. All right, I hope this was helpful. Of course, if you have any questions, please ask.